Good afternoon, dear colleagues. Our RT academic advisor, Mr. Yujanin, would like to present you a video course of practical training of RT specialists in Scientific and Educational Center, Качество. Here we have an object to be tested and a task for radiographic testing. There is also a document consisting of initial data indicating the following: purpose of the inspection, title of the object to be tested, its material, geometric dimensions, type and method of welding, type of edge cutting, length of the section to be examined with X-rays, sensitivity of testing, regulatory and technical documentation and quality requirements. Radiographic inspection is carried out using the following equipment and testing means: X-ray unit with a maximum voltage of 160 kV at 3 milliamps, focal spot of 0.8 mm, image quality indicators, densitometer, optical density line to test densitometer performance, film illuminator, max, auxiliary testing means, visual testing kit, regulatory and technical documentation. The testing equipment must be verified and have calibration certificates. Radiographic inspection requires compliance with radiation safety regulations. We will use a personal dose rate meter and a dose rate meter to determine background radiation. We will start the inspection procedures with a preliminary run of the X-ray unit. This is to train the unit. The training is performed automatically. We are doing it now to measure background radiation.
Во время тренировки измеряем радиационный фон.
Depending on the geometric dimensions of the object to be tested, the sizes of the film sheet and the amplification screens are calculated, and accordingly, the class of the film system is selected. Considering the size of our object to be tested, we concluded that a film sheet of 240 mm by 100 mm will be enough for us. We use Agfa DS7 film, but since the original size of the film sheet is 300 mm by 400 mm, we will cut it and use a part of the desired size. All necessary operations are performed under non-actinic light. Then the film is put into cartridges. The object to be tested is marked with an indelible marker. We indicate the start and the end points of the object to be tested and the origin of the coordinates. Next, we place lead markings at the above-mentioned points and specify the direction of the X-ray examination. Now the object to be tested has all the necessary marks on its surface. A film cartridge and metal screens are installed at the center of the working area. The object to be tested is to be placed right on them. It is necessary to put a wire image quality indicator directly on the weld. It is time to set the estimated focal length and leave the box. Please make sure that there are no people inside the X-ray box. Then close the door tightly. When the door is closed, the limit switch is triggered and the voltage is supplied to the X-ray unit. The X-ray unit is on.
Выставляем рассчитанные параметры.
All the necessary parameters are to be calculated and set. They are voltage, current, and exposure time. The X-ray exposure is now in progress.
И время экспозиции. Производим экспонирование.
During the exposure, the radiation background is to be remeasured. To process the X-ray image, we need the following testing means. Developer. We will use ECFA G128 and fixation. We will use ECFA G328. The process starts with the development of the image. Then we need to wash it and put it into fixing bath. Then the film is to be rinsed and dried. Development is carried out using the ECFA G128 developer. The development time is varying from 4 to 6 minutes. The temperature regime is ranging from 18 to 23 degrees Celsius. The development time depends not only on the temperature regime, but also on the developer's exhaustion. At this stage, washing is performed. After washing, the film is put into fixing bath. Fixing time is twice longer than it is needed for development.
Время фиксирования, двойное время проявления.
After fixing, rinsing is needed. And now we are to dry the film. After drying, it is necessary to inspect the image if it is fit for further interpretation. No mechanical damage to the emulsion layer is allowed. The required testing sensitivity is to be reached. Be sure that all the marks are on the surface of the object. Before assessing the darkening density of the image, it is necessary to check the performance of the densitometer. This is done like this. The previous values are reset to 0, and using the optical density ruler, we check the darkening density. The sensitivity of testing is assessed according to the image quality indicator. In our case, I see the fourth wire on the second iron indicator. The testing sensitivity for this class of welded joint should not exceed 0.3 mm. The actual testing sensitivity in this image equals 0.2 mm. The testing sensitivity is within tolerable limits. Now, the darkening density in the image is assessed. First, we are to reset the densitometer and evaluate the picture of the weld. The values are 2.3, 2.4, and 2.4. And for the heat-affected zone, the values are 3 and 3.1. The darkening density value is within the limits, so we can interpret the image. The task of image interpretation is to analyze the image and assess the compliance of the object to be tested with the requirements of regulatory and technical documentation. Based on the results of testing, a report is drawn up. All the used devices and testing means are to be returned to assigned condition. Thank you for your attention. We look forward to seeing you again.